Hello, good afternoon, students. I hope you all are fine. So, in the last class, we discussed about surface tension of a fluid. We will continue with it. I'm sharing the screen. I hope it is visible to you. So, what exactly is surface tension? Surface tension is defined as the tensile force acting on the surface of a liquid in contact with a gas or on the surface between two immiscible liquids. So, how we are defining surface tension? Surface tension is nothing but tensile force acting on the surface of a liquid in contact with a gas or on the surface between two immiscible liquids. So, which type of liquids you call it as immiscible liquids? The liquids which are not mixable. For example, if you mix petrol with water, what will happen? Petrol will form a layer in between water. So you can easily identify which is water and which is petrol. So this type of liquid is known as immiscible liquid. So how we are defining surface tension? It is nothing but tensile force acting on the surface of liquid in contact with a gas or on the surface between two miscible liquids. So what will be the SI unit for surface tension? Tensile force acting per unit length is nothing but force, tensile force unit is Newton, whereas per meter, that is we are interested in per unit length. So that's why it is Newton per meter. Now the phenomena of surface tension is explained with the help of this sketch, in which what we are assuming three molecules A, B, and C of liquid in a mass of liquid. So what is happening? The molecule A is completely inserted in water, as a result of which it is attracted by all the forces in all the direction. As a result of which the resultant force acting on it will be zero. Similarly, if you see the bubble B, it is 80% inserted in water and 20% outside the surface. So the force acting on it is unbalanced. Whereas if you see the bubble C, it is half inside the water and half above the surface. So as a result of which the surface is acting as a thin film, or surface tension is acting on the molecule C. So now we need to study different cases. Surface tension on liquid droplet in the first case. So what we are doing, we are considering a small spherical droplet of a liquid of radius r. So what we are assuming is small spherical droplet is there whose radius is r. On the entire surface of the droplet, the tensile force due to the surface will be active. So what we are assuming, एक liquid droplet है जिसकी radius is r and surface tension is sigma, and P is the pressure intensity inside the droplet in excess of outside pressure intensity. So D we are assuming as diameter of droplet. So let the droplet cut into two halves. So we are assuming it is not possible to cut the droplet. We are assuming the droplet is cut into two halves. As a result of which the force acting on one half, say left half, will be tensile force due to surface tension acting around the circumference of the cut portion, as shown in the figure 1.11b, is equal to sigma into circumference. Circumference is nothing but pi into d. So this, you can see what it is. It is a droplet. It is cut into two portion, as a result of which tensile force is acting on this portion. So now what is happening? The tensile force, the force acting on the left half of the droplet is equal to sigma into circumference, sigma into pi d. Similarly, the pressure force on the area will be equal to, force is nothing but area into pressure, P into pi by 4 into d square, as shown in the figure. Now, these two forces will be equal and opposite under equilibrium condition. That is, P into pi by 4 d square is equal to sigma into pi into d, or P is equal to sigma into pi d divided by pi into d square by 4. If you cancel the terms, it comes out to be p equal to 4 sigma by d. So this equation, that is equation 1.4 shows that with the decrease of diameter of the droplet, pressure intensity inside the droplet increases. So how we are analyzing the things with the help of this equation, that is P is equal to 4 sigma by D. So what is happening? The pressure is inversely proportional to diameter of the droplet. If the diameter of the droplet is increasing, the pressure will decrease. Similarly, vice versa. So this type of what you can see equation will be helpful while solving the numericals. Now we will see second case in which the surface tension is acting on a hollow bubble. Oh, a hollow bubble like a soap bubble in air has two surfaces in contact with air, one inside and the other outside. So what we are assuming, a hollow bubble is there or a soap bubble, just like a soap bubble. It has two surfaces in contact with air and one surface inside and the other outside. These two surfaces are subjected to surface tension in which in such case P into pi by 4 into d square is equal to 2 into sigma pi d. If you compare this soap bubble case with the liquid droplet, all the things are same, but the only difference is here in case of soap bubble, two faces, two surfaces are in contact with air, as a result of which we are multiplying the circumference by 2. That is P into pi by 4 into d square is equal to 2 into sigma into pi d. If you do the calculation, P comes out to be 8 sigma by d. Now surface tension on a liquid jet. That is the third case. So what we are assuming, consider a liquid jet of diameter d and length as shown in the figure. So what we are assuming, a liquid jet is there whose diameter is d and length is L as shown in the figure. So let us assume that P is the pressure intensity inside the liquid jet above the outside pressure. So what we are assuming, P is the pressure intensity inside the liquid jet above the outside pressure, and sigma is nothing but the surface tension of liquid. So considering the equilibrium of semi-jet, we have force due to pressure. How you are calculating force? P into area of semi-jet. That is P equal to L into D. We are assuming this to be a cylindrical portion. L into D is the area of the semi-jet. Now, force due to surface tension. So, this force due to surface tension is acting on two sides of the length. So, it is equal to sigma into 2L. So, equating the two forces, we will get P into L into D is equal to sigma into 2L, or P is equal to sigma into 2L by L into D. So, L gets cancelled, P comes out to be 2 sigma by D. So I hope you understood all the three cases. Now we will solve some numericals on this. So the first problem is the surface tension of water in contact with air at 20 degrees Celsius is 0.0725 Newton per meter. So how much is the surface tension of water in contact with air? Sigma is given to us 0.0725 Newton per meter. The pressure inside the pressure inside a droplet of water is assumed to be 0.02 Newton per centimeter square. P is given to us 0.02 Newton per centimeter square. If you convert this, it becomes 0.02 into 10 raised to 4 Newton meter square. Calculate the diameter of the droplet of water. So what we need to calculate? Diameter D. So using the equation 1.14, P is equal to 4 sigma by D. P is given to us 0.02 into 10 raised to 4, converting Newton per centimeter square to Newton per meter square. Next 4 into sigma surface tension is 0.0725 divided by D. So D comes out to be 0.0145 meter. If you convert this into mm, it comes out to be 1.45 mm. Now in the second case, We need to calculate, find the surface tension in a soap bubble of 40 mm diameter when the inside pressure is 2.5 Newton per meter square above atmospheric pressure. So how much is the diameter of the bubble? D, 40 mm. If you convert this into meters, it comes out to be 40 into 10 raised to minus 3 meter. Pressure in excess of outside pressure P is given as 2.5 Newton per meter square. So for a soap bubble, what is the equation? P is equal to 8 sigma by D. So P is nothing but 2.5, 8 into sigma divided by D is 40 into 10 raised to minus 3. So your sigma comes out to be 0.0125 Newton per meter. How it comes? Sigma equal to 2.4 into 80, 40 into 10 raised to minus 3 divided by 8. So now we will see one more problem. I guess there was a technical issue. So one more problem is the pressure outside the droplet of water of diameter 0.04 mm is 10.32 Newton per centimeter square. Atmospheric pressure. Calculate the pressure within the droplet if surface tension is given as 0.0725 Newton per meter of water. So how much is the diameter of water? 0.04 mm. So we are converting this into meter. So it comes out to be 0.04 into 10 raised to minus 3 meter. Pressure outside the droplet is given to us 10.32 Newton per centimeter square. So this we are converting it into meter square by multiplying by 10 raised to 4. So the surface tension comes out to be 0.075 Newton per meter. The pressure inside the droplet in excess of outside pressure is given by the equation P is equal to 4 sigma by D. So 4 into sigma value is 0.0725. D is nothing but 0.04 into 10 raised to minus 3. So if you do the calculation, it comes out to be 7250 Newton per meter square or 0.75 Newton per centimeter square. So pressure inside the droplet is equal to P plus pressure outside the droplet. So P is nothing but 0.725. Pressure outside the droplet is 10.32. So if you do the calculation, it comes out to be 11.045 Newton per centimeter square. I hope the concept is clear to you with regard to surface tension. Now we will see one more phenomena or one more property that is known as capillarity. So what is capillarity? Capillarity is defined as a phenomena of rise or fall of a liquid surface in a small tube relative to the adjacent general level of liquid when the tube is held vertically in the liquid. So how we are defining capillarity? क्या है capillarity? एक ऐसा फिनोमिना है जिसमें राइज भी हो सकता, फॉल भी हो सकता एक लिक्विड सरफेस का. See, if you see the sketch, how we are assuming capillarity is defined as phenomena of a rise or fall of a liquid surface in a small tube. We are assuming a small tube, glass tube is inserted in a beaker containing water. or liquid, what is happening? There will be an increase in the level of liquid or there will be decrease in the level of liquid. Both cases are possible. If suppose there is a rise of liquid surface, then it is known as capillary rise. If it is a fall of liquid surface, then it is known as capillary depression. It is expressed in terms of centimeter or of liquid. Its value depends upon specific weight of liquid, diameter of the tube, and surface tension of the liquid. So, on what factors capillarity depends? It depends on the specific weight of the liquid. Next, diameter of the tube and surface tension of the liquid. On these three factors, the surface capillarity of fluid depends. Now, expression for capillary rise. Now, we are assuming or calculating an expression for capillary rise with the help of this sketch. So, what we are assuming? We are considering a glass tube of small diameter D open at both ends and is inserted in a liquid, say water. So, how we are calculating? We are considering a glass tube of small diameter D open at both ends. The tube is open at both ends so that the fluid can flow in it. In a liquid, say water, the liquid will rise in the tube above the level of liquid. So what we are assuming? We are assuming let h is equal to height of the liquid in the tube. Under a state of equilibrium, the weight of liquid of height h is balanced by the force at the surface of the liquid in the tube. But the force at the surface of the liquid in the tube is due to surface tension. So how we are calculating the capillarity? We are assuming h, small h is equal to height of liquid in the tube. h क्या assume कर रहे हैं? Height of liquid in the tube under state of equilibrium. Equilibrium में क्या हो रहा? The weight of liquid of height h is balanced by the force at the surface of the liquid in the tube. ये जो स्टेट ऑफ इक्विलिब्रियम क्या हो रहा है? ये जो वेट ऑफ लिक्विड ऑफ हाइट एच है, इसको कौन बैलेंस कर रहा है? जो टेंसाइल फोर्स एक्ट कर रहे हैं लिक्विड सरफेस पे, दैट इज ड्यू टू सरफेस टेंशन. So that's why we are assuming let sigma equal to surface tension of liquid, theta is equal to angle of contact between liquid and glass tube. Next, the weight of liquid of height h in the tube is equal to area of tube into h into rho into g. So what, how we are calculating the weight of liquid of height h in the tube? Area of the tube into h into rho into g. So area of tube is nothing but pi by 4 into d square into h into rho into g. So where rho is the density of the liquid. Now vertical component of surface tensile force is equal to sigma into circumference into cos theta. First equation is weight of liquid due to surface tension. It comes out to be area into h into sigma into rho, where sigma is rho is nothing but density of liquid. Now vertical component, vertical component of surface tensile force. This we are calculating in terms of sigma into circumference into cos theta. Sigma into circumference is nothing but pi into d cos theta. So if you equilibrate equation, both the equation, what you get, pi by 4 into d square into h into rho into g is equal to sigma into pi d into cos theta. If you do the calculation, h is equal to 4 sigma cos theta divided by rho into g into d. So the value of theta between water and clean glass tube is approximately equal to 0, and hence cos theta is equal to unity. Then the rise of water is given by, we are modifying the equation because cos 0 is 1, your h comes out to be 4 sigma by rho gt. I hope we have understood what you mean by capillary rise and what is the equation used to calculate the capillary rise. Now we will go to one more definition derivation, that is known as expression for capillary fall. So how we are calculating capillary fall? If the glass tube is dipped in mercury, the level of mercury in the tube will be lower than the general level of the outside liquid as shown in the figure. So what is happening? अगर ग्लास ट्यूब इंसर्ट करें मर्क्यूरी में, फर्स्ट केस में क्या करे थे हम? ग्लास ट्यूब को लिक्विड में इमर्स करे थे जहाँ पे कैपिलरी राइज हुआ था. यहाँ पे क्या हो रहा? इफ द ग्लास ट्यूब इज डिप्ड इन मर्क्यूरी, द लेवल ऑफ मर्क्यूरी इन द ट्यूब will be lower than the general level of the outside liquid as shown in the figure. So what is happening here? जैसे ही आप मर्क्यूरी में इंसर्ट करें आपका ग्लास ट्यूब दोनों एंड्स ओपन रखे, इसका जो लेवल है नॉर्मल लेवल से भी नीचे गिर गया. Then in equilibrium, two forces acting on the mercury inside the tube is first one is due to surface tension acting in downward direction and is equal to sigma into pi d into cos theta. First force due to surface tension is given by sigma into pi d into cos theta. Second force is due to hydrostatic force acting upward and it is equal to intensity of pressure at a depth h into area. So we are equating the two forces. First force is due to surface tension. First force due to force acting in the mercury tube, and which is due to surface tension in downward direction, which is equal to sigma into pi d into cos theta. The second force is due to hydrostatic force. The second force is due to hydrostatic force acting upward and it is equal to intensity of pressure at a depth h into area. So if you equate both the equations, what you get? Sigma into pi d into cos theta is equal to sigma into rho g h into pi over d square. So where h comes out to be 4 sigma cos theta by rho g d. Whereas the value of theta for mercury in glass tube is 128 degrees. This also you should remember what is the value of theta for water, what is the value of theta for mercury. So theta for water is 0, cos 0 is 1, whereas theta for mercury is 128 degrees. If it is given in the problem, it's well and good. If it is not given, you have to assume it. Now we will solve some numerical problems on this capillary rise and capillary fall so that you will get an idea. Calculate the capillary rise in a glass tube of 2.5 mm dia when immersed vertically in a water and a mercury. Take surface tension sigma is equal to 0.0725 Newton per meter for water and sigma equal to 0.52 Newton per meter for mercury in contact with air. The specific gravity for water is given as 13.6 and angle of contact is given as 130 degree. So once again, you read the problem, then only you should solve it. So what you need to calculate? You need to calculate capillary rise. Calculate the capillary rise in a glass tube of 2.5 mm dia. How much is the dia? We are assuming 2.5 mm dia. We need to calculate capillary rise H. T is given to us 2.5 mm. When immersed, first case it is immersed in water. Second case it is immersed in mercury. So it may be capillary rise, or it may be capillary fall. Both chances are available. Take surface tension sigma is equal to 0.0725 Newton per meter for water and sigma is equal to 0.52 Newton meter for mercury in contact with air. So surface tension for water is different, surface tension for mercury is different. The specific gravity for mercury is 13.6 and angle of contact is given as 130 degree. So don't get confused. Theta is equal to 120 degree for mercury is standard value, but in the problem theta is given as 130 degree. So if it is given, you have to take that value only. So first case, first of all, what are the things given to you? Diameter of tube is given as 2.5 mm. So if you convert this, it comes out to be 2.5 10 is to minus 3 meter. Surface tension sigma for water is 0.075 Newton per meter. Sigma for mercury is 0.52 Newton per meter. Specific gravity of mercury is 13.6. So if specific gravity is given, density you can calculate 13.6 into density of water. So it comes out to be 13600 kg per meter cube. Now, first case, capillary rise for water, theta is equal to 0. So, using this equation, H is equal to 4 sigma cos theta divided by rho GD, cos 0 is 1. So, that's why 4 sigma is how much? That is for surface tension for water, 0.0725. Rho is 1000, G is 9.81, D is 2.5 into 10 is to minus 3. So if you solve it, it comes out to be 0.118 meter or 1.18 centimeter. So in the second case, you need to calculate surface tension for capillarity for mercury. So angle of contact between mercury and glass tube is given as 130 degree. So using the same equation, that is H equal to 4 sigma cos theta divided by rho GD. 4 sigma is this Values change. Surface tension values change. It is 0.52 cos 180 divided by rho is 13.6 into 1000 density. G is 9.81. D is 2.5 into 10 raised to minus 3. So if you do the calculation, it comes out to be how much? H is equal to minus 0.04 meter or minus 0.4 centimeter. So this negative sign indicates that there is a capillary depression. So before solving only you have got an idea, because it is mercury, there are possible chances that there may be a capillary fall in the tube. So the answer justifies it. So one more problem will solve that will be helpful for you. So it is a question of UPSC engineering exam also for 1974. So calculate the capillary effect in millimeters in a glass tube of 4 dia when immersed in water and mercury. The temperature of liquid is 20 degrees Celsius and the values of surface tension of water and mercury 20 degrees Celsius in contact with the air are 0.073575 Newton per meter and 0.51 Newton per meter respectively. And the angle of contact of water is 0 and that for mercury is 130 degree. So it is not 1.3 degree, it is 130 degree. Take density of water at 20 degrees Celsius is equal to 998 kg per meter cube. So it is a question of UPSC engineering exam 1974. So what are the things given to you? Diameter of tube is given to us D equal to 4 mm. So if you convert this into meter, it will be 4 and 10 is to minus 3 meter. The capillary effect, the capillary rise or depression is given by the equation. X is equal to 4 sigma cos theta divided by rho GD. So capillary effect for water, first case. Sigma is given to you, theta is given to you, rho is also given to you. So if you do the calculations, it comes out to be, H comes out to be 7.51 mm. First case. Second case, what we are doing, capillary effect for mercury. Sigma is different, that is surface tension is different, 0.51 Newton per meter. Theta is also different, 130 degree. And density is not given to you. You need to calculate the specific gravity is given to you, 13.6 into 1000. It comes out to be 13600 kg per meter cube. So here H is equal to 4 sigma cos theta divided by rho GD. So if you do the calculation, it comes out to be 2.46 into 10 raised to minus 3 meter. Again, it is a negative sign. It indicates it is capillary fall or depression. Many problems are there, but what we will do is we will solve some another problems, additional problems, because capillarity, I hope you have got an idea. Or else one more problem we will solve. Still some time is left. Okay. So find the minimum size of glass tube. D you need to calculate minimum size of glass tube that can be used to measure water level if the capillary rise in the type is in the tube is to be restricted to 2 mm. H is given to you. Capillary rise is 2 mm. And because it is a capillary rise, you can take it as positive. 2 mm or 2 into 10 is to minus 3 meter. Consider surface tension of contact within air is 0.073575 Newton per meter. So the surface tension is given to you. Capillarity is also given to you. You need to calculate diameter. Capillary rise is H is equal to 2 mm into 2 into 10 raised to minus 3 meter. Surface tension sigma is equal to 0.073575 Newton per meter. D diameter of the tube. Angle of water, angle theta for water is 0. If it is given, if it's okay. If not, you have to assume it. Density of water is 1000. So your H comes out to be 4 sigma. Cos theta is cos 0 is again 1. Rho GD. If you do, rho is nothing but 1000 into G is 9.81 into D. So if you do the calculation, it comes out to be 0.015 meter or 1.5 centimeter. One more problem is there. There is no need to solve it because it is somewhat different. It is of Delhi University. We will just recall the things which what we have studied today. starting with surface tension. So what was surface tension? Tensile force acting on the surface of a liquid when it comes in contact with a gas or between two immiscible liquids which cannot be mixed. The SI unit of surface tension is Newton per meter. And if you see here, three bubbles are inserted. A bubble A is completely inserted inside the water. So the resultant force acting on it will be zero. Similarly, bubble B is 80% inserted inside and 20% above. So it is the force acting on it is in unbalanced. Whereas the what you can say bubble C is half inserted and half acting are subjected to atmosphere, as a result of which the thin film is acting with between, so it is known as surface tension. Now there are three cases of surface tension. Surface tension of liquid jet, which is calculated using the formula P is equal to 4 sigma by D, or sigma is equal to PD by 4. Similarly, surface tension of hollow bubble is given by P equal to 8 sigma by D, or sigma is equal to PD by 8. And surface tension of liquid jet is given by sigma is equal to PD by 2 sigma. Sorry, sigma is equal to PD by 2. Is it PD by 4, PD by 8, PD by 2? Numerical problems also we solved. Next we saw capillarity. So what is capillarity? It is nothing but phenomena of rise or fall in the level of liquid surface when a glass tube is inserted in water with both of its end open. If there is an increase in the level of tube, then it is called capillary rise. If it is a decrease in the level of water, then it is called capillary fall. So what you can say, theta for water is 0, theta for mercury is 128 degrees standard value, and density of water is 1000. So H is equal to 4 sigma cos theta by rho g d. So this completes our theory part. We will solve additional problem in the next class.